So here we are for Bob's birthday celebration. Surprise! Okay. All right, so a couple historical aspects here, and then we'll get into Bob and ICDD and the Powder Diffraction File. So Bob wasn't here when
either of them.
Dubai, Scherer, and Hull simultaneously were working on the concept of powder diffraction. The issue at that point was people believed if you took a single crystal and you ground it up, you destroyed the crystalline. But what they showed, in fact, was you got these polycrystalline patterns. But Dubai and Scherer were the first to publish, and we refer to it as the Dubai-Scherer technique. But it was Hull in 1919 who showed that if you combine two different materials, you could actually use the powder technique for phase identification. In other words, you didn't get a new diffraction pattern, you had the two individual patterns that were part of your data collection. It became really the large industrial process through the Dow Chemical Company. This was a picture from 1934. And you can see the apparatus they had 12 cameras around an X-ray source, 2 samples per camera, so they were collecting 24 diffraction patterns at any given time. And with this large amount of data, they started to put together really a diffraction database. This is a paper that was published by Hanawalt, Brennan, Rietvald in 1938, and it was not just a series of diffraction patterns, about 1,000 patterns were published, but it was a methodology for how to do phase identification. And this is the original Hanawalt manual from Dow, where they recorded their information. When I show this to a group particularly of young individuals, I like to point out we call this a book. The number of today, you know, it's your phone, it's your tablet. The other thing I like to point out is that they did realize sometimes they got it wrong. They misidentified a material or they had the wrong indication. And when they did that, they would draw a line through the entry, and we like to call that the delete key back at that time. But it was this information and with this publication that the Powder Diffraction File had its origin in 1941. And with ASTM, the American Society of Testing Materials, they took most of the data that was in this publication, and they in fact made these diffraction cards, something a term people still use today, even when it's the electronic version. This happened to be card number 1. It's for bismuth organometallic, and at that time, you had a list of the D spacings, the 3 D spacings for the 3 most intense peaks. The intensity was relative to 1, not 100 or not 1,000, but 1 was the most intense peak. If the unit cell was known, it would be included. Oftentimes it wasn't at that point. They were handwritten, and the person who put this card together was Don Hanawalt, because they would put their initial down here in the bottom of the card. So that was really the start of the Powder Diffraction File. This is the Hanawalt manual today. This is the search manual. So everything, of course, is now electronic. And beyond just searching for chemistry, there are a number of features that you can use for trying to get your phase identification, but also materials characterization. Now, the database itself does have data that has originated from ICDD, and with our partnerships with FIS, Cambridge, NIST, and MPDS with the Linus Pauling file, it brings a complete data set together of over 1 million entries for phase identification and characterization. One of the things that's in here is that beyond people doing some kind of chemistry search, there are a number of other search components here. One of them includes authors, references. And if you put in the author von Dreele for the search here, there are 172 entries that are in the database. And there's a combination, some of them are organic, some of them inorganic. And if you look at a particular entry here, sodium copper oxide, you have one of the papers that is in fact authored by our guest of honor, Robert von Dreele, but also we see Vic Yund is on this paper as well too. And it's from these data the data that are in these papers that are included in the powder diffraction file. I mean, that's how the powder diffraction file grows, by getting more data like this. So if you take the information from the publication, you now come up with today's PDF entry, okay? Again, as I mentioned, some people still call them cards, okay? But electronically, it is an entry. And the historical is still there, the despacings, intensities. But if you happen to want to say, well, what radiation am I working with? You can change your radiation. You can make it synchrotron. You can also look at if the structure is present. This is key. Having the structure available in the atomic coordinates now allow you to expand the use of the powder diffraction file beyond just phase identification. And so if you say, what can I do besides the phase ID? Well, you can get a simulated powder pattern, whether it's laboratory or synchrotron data. You can simulate the time of flight neutron pattern, bond length distribution, structure itself, but you can now also look at electron diffraction capabilities, such as backscatter. You can look at 2D ring patterns, Lowy patterns, selected area electron diffraction patterns. So it expands significantly the capabilities of not only phase ID, but materials characterization. Now, we have sort of the qualitative aspect of it is, and a lot of times someone will come in for the powder analysis and say, can you tell me what I have? And you do that. And then after you've done that, they say, well, can you tell me how much? Okay, and the how much is often the more difficult consideration because of some of the issues with powder data. But some of the early quantitative phase analysis in 1925, Navius published what's probably one of the earliest or first papers where they made a series of molite, feldspar, and clay mixtures. And with these mixtures, they made a series of calibration curves to try to do the molite content. You then have one of the papers, this is by Clark and Reynolds, where they used an internal standard method, such as zinc oxide, calcium fluoride, and they were trying to look at quartz really in sort of respirable quartz type analysis, okay? That brings us now to Rietvald techniques. And for many years, you know, we had Rietvald, but you needed software that was what we would call user Rietvald. And so at ICDD for a number of years, we have taught a Rietvald clinic. And for a number of those years, we were using GSAS. We call it GSAS-I, but we use GSAS. And this is the Von Dreele Larson version. And we use this as the teaching tool because it allows you to get into some of the nitty-gritty about what are the effects of different parameters on your profile and your analysis and being able to do some kind of quantitation on materials. The clinic itself has evolved, and in one of the lines we have here is that we have switched over, and for a few years now we use GSAS-II, okay? And with the GSAS-II, we now have the Toby Von Dreele version, but now you have many, many more features. And we heard a number of them here today, particularly things like being able to work with 2D data. You can work neutron data easily, lab data, synchrotron data. But again, the aim is the same to, in one aspect, can you do some quantitation of phase or phases that are present, including the thoughts around amorphous material? What's the amorphous content of your material there? Now, for our Rietvald clinic, we have two principal instructors, Jim Kadick and Joel Reed. Joel is from the Canadian Light Source. Jim, I sort of like to say, is from everywhere. Illinois Institute of Technology, North Central College. He has his consulting firm, Polycrystallography, Inc. So they both ask that I say, thank you, Bob, because, you know, they enjoy teaching GSAS. They enjoy teaching Rietvald. And so, yes, they're able to work with GSAS-II. And thank you for letting us have GSAS to use for our clinics, okay? This is what happens after you have a clinic. They hold up their certificates. They're actually smiling because it's Friday. We finished. They survived a full week of this, okay? It's intense, okay? There's a lot to learn. But the thing that is important is that you're bringing in new groups, new scientists, new people who are learning how to do the analysis, and GSAS is an important part of that because this is the group, although with the exception someone who was not born with the rest of us here, we won't be doing this forever, okay? And we need more people involved, and so this is really where we get involved with our clinics here. Finally, just a comment that Bob has been recipient of awards from the Denver X-ray Conference and ICDD. 2009, it was the Barrett Award. This is for continuous contributions to the field of X-ray diffraction. And the Hannah Walt Award, it's basically saying someone who's done something big, really, really big. Okay? I mean, Hannah Walt started the whole powder diffraction phase identification technique. And so in 2013, I had the privilege with Bob at the Denver X-ray Conference to present the Hannah Walt Award. And so congratulations to Bob on those. Okay, so with that, just a very short thank you on behalf of ICDD. Thanks, Bob, for your contributions to the community. Thank you, and we appreciate everything.